Good afternoon and welcome to our post-flight news conference with NASA astronaut Kate Rubins, who has just returned from the International Space Station after a 185-day stay in space. After launching back on October 14th, she and her crewmates Sergei Ryzhikov and Sergei Kuznetsov landed in Kazakhstan at 11:55 p.m. Central on Friday, and she's spent the last few days readjusting to Earth's gravity. We have about 30 minutes with Kate for questions, and we'll be taking them from our reporters on the line with us. You can press *1 to raise your hand or *2 to withdraw your question if it gets asked. And we'll also be taking questions from social media. If you're following along at home, you can submit yours using the hashtag #AskNASA. We'll get started on questions in just a moment, but first I wanted to give Kate the opportunity to say a few words. Kate?
Hi, it is actually really wonderful to be with you today. It's so great to be back on the planet. Space is incredible. I really enjoyed this mission. It was 185 days orbiting the Earth, but it was a wonderful thing to land and to be with you all, and I'm looking forward to your questions today.
Okay, we are going to start with some from social media. Just a reminder to the reporters online that you can press *1 to enter your question. Let's go to Haley from White County, Illinois, on Twitter, who is asking if COVID-19 affected any research on the space station in any way.
Yeah, Haley, that is a great question. Of course, COVID's affecting everything on Earth, and even things like how we process scientific samples that are going to be launched to the space station. So as you can imagine, a lot of the research team had to deal with things like delays, slowdowns in their research, difficulty with logistics and shipping, and figuring out a completely new way to do things. Despite all of this, it was actually incredible. We got almost all of the experiments that were planned to launch on this mission were launched. We conducted hundreds of experiments on board the International Space Station, and to think that everybody was able to do that with all of the challenges and the delays, it's pretty impressive. It's a testament to the International Space Station program.
Absolutely is. Okay, one more from Twitter from Blaine, and he asked, were there any surprises with the experiments that you were working on?
Blaine, that's a good question. We sometimes don't know what to expect when we do science on the International Space Station. That's the reason that we do things in microgravity. I was quite surprised, actually, by some of the larger tissue architecture experiments that we were looking at. So when we were looking at tissues in 3 dimensions, which is a little different than we've done before, we could see changes in the behavior of the tissues, how they organized, for example, how the heart cells were beating. We saw some really interesting surprises with some of the C. elegans experiment. These are nematodes. These are small worms, and their behavior in space actually reminded me a little bit of astronaut behavior in terms of how we slow down and move around. So we made some of those notes during the experiment. This is going to help the researchers out to find such a difference in microgravity.
That is so cool. Okay, we're going to take some from reporters now on the phone line. One more reminder to press *1 if you have a question on the phone bridge. Let's start with Paul Brinkman from UPI.
Yes, hello. Thanks for taking my question. Kate, there are more crew spacecraft being developed all the time now, and I'm just wondering, as an astronaut, do you pretty much want to fly on as many types of spacecraft as possible? And specifically, what are your impressions of Crew Dragon and Orion, compared to Soyuz, I guess?
This is a very exciting time for human spaceflight to see this many spacecraft in development, and a lot of them have their own purpose. So, for example, Orion is a spacecraft that's really going to take us into exploration, to the moon, into deep space and beyond. And so, yes, as an astronaut, you'd like to fly as many missions as possible. My crewmate, Soichi Noguchi, has actually flown on 3 different spacecraft, Soyuz, Shuttle, and Crew Dragon, and so we were asking him all the time to give us kind of these comparisons. These are all incredible spacecraft. They're very capable. For me, it's really wonderful to be able to be up there on the International Space Station when Crew 1 launched. This is an exciting time for America in human spaceflight to have our own capability. The fact that those guys are launching from Florida and landing not too soon, it's incredibly exciting, and I really encourage everybody to watch this coverage. This is a chapter in spaceflight that's new. It's exciting. We haven't seen this kind of thing before.
All right, let's go to Mark Crow next from Aviation Week.
Thank you. How were you able to advance your previous work in the sequencing of DNA, and do you have some examples of advantages you think this could bring to the future of space science and exploration?
Thanks, Mark. Yeah, we were able to advance quite a bit from the 2016 initial sequencing. So since I was back on Earth in the interim, that team actually developed a lot of different ways of processing samples, so they could go straight from a swab to a sequence, which was really important if you're looking at microbes or environmental samples or even human samples. We're also able to process more samples. So we started doing something called multiplexing, where you attach a DNA barcode to each individual sample. And then you can mix those together and you can run one sequencing reaction. And we were running 8 when I was on board, but you could do 96, you could do 1,000. And so you really are able to expand your throughput. I got a chance to go do, they let me do a little bit of the sampling that I was interested in. So we sampled some interesting microbial locations as well as negative controls. And then we did a really big experiment. The sequencing will be done on the ground, but we sampled about 800 different environmental samples on the space station. So a full spatial map of the International Space Station. That was one I've been talking about for years, and I was lucky enough to be up there when we were doing it.
All right. Next, we have I think a student reporter from the student paper at Vintage High School, which I think you're familiar with.
Hi. First of all, I just want to say thank you so much for reaching out and asking me to come ask you a question. I did go around the Vintage campus and, got to talk to some teachers about possible questions to ask you. Vintage is super happy, super proud of having an astronaut that's graduated from our school. It's a huge inspiration. So our question that we came up with as a student at Vintage, we were wondering if you ever saw yourself becoming an astronaut. And we were curious if that was the case, if you had any inspirations or just how that came to be.
I had a lot of inspirations at Vintage High School, actually. AP Biology was certainly one of them. So I always wanted to be an astronaut, but I also wanted to be a biologist and a molecular biologist. One of the things I can most clearly remember, this is not new technology now, but it certainly was then, was being able to run out DNA strands on a gel and interpret those. This was a pretty big deal for a high school class, and that made me feel, it was one of the first things that we did in AP Biology that made me feel like, oh, I could be a real molecular biologist someday. So certainly a lot of inspiration, and I hope kids are finding that in their science classes these days at Vintage as well.